I'm gonna mute. Maybe not. Okay. So we are going to be doing a check-in type virtual session today, which means that we're going to go through a bunch of different problems. We're going to do some dimensional analysis. We're going to do some sig fig, and we're going to practice doing the mole conversions that you should have been able to do in the mole lab. So, and then we're going to have time for you to ask questions about specific things maybe that you're confused about or that you got wrong, etc. So what we're going to do is I'm going to try to get some of these windows out of my area. All right. We are going to start with our objectives. We're going to review the metric system. We're going to practice dimensional analysis, and we're going to review moles and how to convert from mass to moles and atoms, and also sig figs, which I did not include on here, but that kind of goes in with all of these other concepts. So the warm-up is we're going to spend 2 minutes. Go to your grades for this class and write down any questions you have. You might not have questions, right? So you might, I don't know, go through your stuff and be like, I'm good, I understand everything. That's fine, but just look at your grades right now, spend about 2 minutes writing any questions down you have. We'll come back to those at the end. All of our check-in sessions are going to start with this exact thing. You guys trying to figure out if you have questions, because I know sometimes you're not really taking the time to do that. And that's what I'm here for, is to answer your questions. So, questions 1 through 3. We're going to do some dimensional analysis. We are also going to really quickly review the metric system. So let me see if I can make my, I made Lotus bigger, but not me somehow. How do I pin myself? Pin, there we go. All right. Hopefully, is this view big enough for you guys to be able to see? I think it should be, right? The question is, it's backwards. How do I fix that? Okay, I might have to do it a different way. So what we're going to do is I will show you in a different app my writing. Write down these 3 questions because we're going to try to solve them together here. So we're going to be converting 300 grams per milliliter into milligrams per kiloliter. We're going to convert 1 gram per hour into gram per second. And we're going to convert 1,000 milliliters per day into liters per year. Okay. And in order to view it, there we go. We're going to view it in this presenter thing, where it's actually the correct direction and not backwards. All right, so remember quickly before we start solving these, the metric system, right? Our main parts of the metric system are the meter, the gram, and the liter. And because the metric system is beautiful and arranged in powers of 10, we can easily migrate between different conversions here. So, in fact, let me pull up the full thing here because we don't use every single one of them. So I don't even remember what some of them are, but here we go. This is a beautiful, beautiful picture here that you can access in Google Images. That gives you a really nice concept of how this works, right? So the basic units are our grams, meters, liters. Then we go to deci, centi, and milli. And then if we go to the left, we go to deca, hecto, and kilo. Okay, there's more, right? But these are the basic ones. And honestly, we don't really use deci. You don't really see that one so much. Deca, pretty much never used. Hecto, pretty much never used. Right, good to know that they're there, but doesn't really impact us much. You might see them though. So remember, we can just move the decimal. So whatever our number is here, let's say it's a 1, we can move the decimal to the right or to the left to convert to these situations. So 1 gram, if we want to make it into milligrams, we're going to put a decimal after our number. And to get to milli, we have to move 1, 2, 3 places to the right. 1, 2, 3. We add in some zeros. And that tells us that 1 gram is equal to 1,000 milligrams. Similarly, if we want liters and we want to find out kilos, for example, 1 liter, this time we're going to be moving the decimal 1, 2, 3 places to the left. So we'll put our decimal place after the 1. 1, 2, 3. Add our zeros, and we find out that 1 liter equals 0.001 kiloliters. Okay. That was a little review because we are going to use some of that information to solve our questions. How are you guys feeling about this so far? Awesome, I see thumbs. Okay, so let's try to solve this first question here. 300 grams per milliliter, we want to convert this into milligrams per kiloliter. I am going to solve it at the same time as you guys, and then we'll go over how to do it, but see if you can at least set it up, or you can at least figure out how to convert grams to milligrams, right? If you can do any of the parts of it, that will be helpful. And if you happen to get an answer, if you want to pop that in the chat, we'll see if we get the same answer. Interesting thing is, guys, I made these questions up and I haven't solved them yet, so we're learning together. Great. I'm hearing a lot of feedback. I might mute some people, see if that helps. Okay. Feel free to unmute yourself if you want to speak. We have a pretty small group here. Did anyone get an answer yet? This one is a really big number, by the way, if you're worried. Oh, actually. I'm trying to remember where I put my calculator. Okay, well, I'm going to start going over this one. I don't know if you guys got an answer yet, but what I got, I don't know why my document camera is spazzing out because I'm definitely not moving like that. Okay. What I did here was, well, that's really weird. It's like doing an insane thing. What is going on? Hold on a second. See if it. Okay, that was weird. It was like spazzing out there. So we started with 300 grams per milliliter. So I put my 300 grams over my milliliters, right? There's an implied 1 there. We want to change from grams into milligrams. So the first thing I did was figure out how many milligrams are in a gram. And we did that already. There's 1,000 milligrams in 1 gram. So I'm going to be putting 1,000 milligrams here. That gets rid of my grams. Now I'm in milligrams, which is what I want. Now I just have to get from milliliters to kiloliters, which I actually did in 2 steps just because, I guess, what's the word I'm looking for? Oh, sweet, I figured out how to get myself on there too. Because that's what made sense to me. You could have done it in 1 step as well. But in 1 milliliter, right, or in 1 liter, there's 1,000 milliliters. So that's the conversion that I used. And then in 1 kiloliter, there's 1,000 liters. So that crosses out my milliliters, crosses out my liters, and I'm left with milligram per kiloliter, which is what I wanted. Right, I actually got 3 times 10 to the 11. So that's 3 with 11 zeros after it, milligrams per kiloliter. So it's a huge number. You could have said how many milliliters were in a kiloliter right here and just done 1 step. Did you guys get the same thing as me? Yeah? Okay. The next one, we're trying to go from grams per hour to grams per second. This one's a little easier because there's less conversions going on. We have our 1 gram per hour, right? And these are all conversions of minutes and seconds here. So I know in 1 hour, I have 60 minutes. And in 1 minute, I have 60 seconds, right? So keep in mind, I'm just trying to get my units to cancel out so that I'm left with the right unit. And all I'm doing is putting in conversion factors that I know. So in this case, I'm just going to divide 1 by 60 twice. And I got 0.0028 grams per second. Right, I actually got this, but I rounded to 0.00278 or to 28. Okay, and then our last one, let's try to solve it. Actually, you guys tell me. Type 1 in the chat if you want me to walk you through how to solve it, or type 2 in the chat if you want to try to solve it first, and then we'll go over it. Okay, people are brave and want to solve it. Awesome. So I'll give you a couple minutes here to try to solve this last option. We're going from milliliters per day to liters per year. Oh, the math on this one worked out pretty interestingly. Did you guys get an answer? Not yet? All right. I'll be patient. I'm sorry. They get really excited about math. $36.5. I got 365 actually. So I could be wrong. Let's check. 1,000 milliliters per day, right? That was the question, right? Okay. So I said there's 365 days in a year, and there's 1,000 milliliters in a liter. So then your thousands actually just end up canceling out. You could also multiply it out. Multiply by 1,000, then divide by 1,000, and you get 365. Did you divide by something different? Oh, 100. Okay. Yeah. So then that's where this can get super frustrating, because if you are off by one digit, like the whole thing is ruined, which is frustrating. Yeah, so that was just a little practice review of dimensional analysis. I know this is hard stuff. Remember, this is college level stuff. So even if you're getting 60% of it, that's awesome, right? And the whole class is not going to be this. Don't worry, we're going to get into reactions and a bunch of other stuff where we won't really be using this. So I picked a couple challenge ones though, because you guys know I love dimensional analysis a little bit more than should be possible, but it's fun to me. So this is a challenge question that we're going to try to solve. Okay. You find 13,406, 109 pennies. 13, not 13,000, 13, whatever. I can't read numbers. You guys know what I'm saying. How many dollars did you find? If each penny weighs 0.01 grams, how much do your pennies weigh in kilograms? Okay, so we have two questions here. First, we're going to solve for the dollars, and then second, we're going to be solving for the weight. So as a quick little reference here, how many pennies are in a dollar? 100, right? Just in case you didn't know that. I just somehow deleted my camera. Zoom is driving me nuts today. It's like not, here we go. I'll just have myself humongous. There we go. Okay, so we know that there are 100 pennies in $1. So that's going to be an important conversion here. They're also telling us that 1 penny equals 0.01 grams. So those are two conversions that we're going to need. 1 penny equals 0.01 grams, and 100 pennies equals $1. So see if you can solve this question. Wow, the plural for pennies looks really weird now that I'm looking at it. These are the things I think about when I'm doing math. All right, you guys let me know when you either are stuck or you think you have an answer and you want to go over it. Excellent, Janie Mae. I got the same exact stuff as you. So, if you're still working, it's cool. We'll go over what to do here. So, our first one, we just needed to find out dollars. So, we knew that we found this many pennies, right? Again, that would have sucked to count all those pennies, but I'm glad we didn't do that. There's an implied 1 here. You don't have to put it. I did, right? I like all my stuff to be in nice, even boxes. We know that in $1 there are 100 pennies. So all we did was take our amount of pennies and divide by 100. Pennies cross out, and we're left with dollars, and we get $134,000 and $61,000.09. Man, I really suck at reading numbers today. Meanwhile, then we want to convert into the mass of the pennies. So we have to start back with our original amount of pennies. We know that 1 penny is 0.01 grams. And we know that there are 1,000 grams in 1 kilogram, right? Because remember, we want to get to kilograms here, not just grams. So if we take our pennies, we multiply by 0.01 and then divide by 1,000, we end up getting 134.06, and if you didn't round there, 109 kilograms, which is a lot, right? That's a lot of kilograms. That's a heavy amount of pennies. Even in dollars, that would be heavy. Okay? There's one more part to this question. Dun, dun, dun. If a movie ticket costs $8.50, how many movie tickets can you buy with your pennies? So recall, we already solved for dollars. Or you could set this up with dimensional analysis, which is what I would recommend, even though you could solve it differently. All I'm going to say is you need to have a lot of friends if you're going to buy this many movie tickets. Okay, so you might have thought, well, I don't need dimensional analysis here, which is true, right? You could have just taken the dollar amount that we got before and divided by $8.50, right? Because you think, oh, we have this much money. If we divide by how much it costs, we'll get the number of tickets. That's true, right? But hopefully you set it up in dimensional analysis, and it will literally show you that that's exactly what you should have done. I ran out of space here. It's a little messy. Sorry about that. The answer is there. But we take our amount of pennies. We use our conversion again between dollars and pennies, 100 pennies and a dollar. And then we want to get rid of dollars and we want to get movie tickets. So we put our $8.50 on the bottom and our movie tickets on the top. Right? If we cancel out all our units, then we end up getting 15,771.90 tickets, which is a lot. A lot of movie tickets. Okay. Next up, we're going to talk about moles. And we're almost done, I promise. We're going to talk about moles, and then we're going to talk about sig figs. And then we will take questions from you guys if you have any. So in the mole lab, right, we had quite a few steps that we needed to do in order to calculate our moles. First thing was we needed to find the molar mass of whatever our compound was. Then we had to convert to moles. And then finally we could wow, I can't spell. Convert to moles, and then we had to convert to atoms. Right? Those are like the 3 basic steps. So I picked a new compound here so that we could practice together. We're going to find, first of all, the molar mass of acetic acid, which is vinegar. CH3COOH is actually how that is written out. That is vinegar, or acetic acid is the science name for it. And there's a reason that these oxygens are written separate like this, right? That it's not O2. So that's important. We will talk about that more when we learn about bonding of compounds. But regardless, how do we find the molar mass of our vinegar? Periodic table, exactly. Right, so we're gonna conveniently, really conveniently, because it could be much harder than this, the periodic table is gonna show us the molar mass of each of these elements. So we need to know for carbon, hydrogen, and oxygen, right? And then we'll figure out how many of each of those we need. So we're gonna just Google a periodic table. Just click on any of them, it really doesn't matter, as long as they have a mass, which they should if it's a good periodic table. Of course, this is the tiniest periodic table of all time. Okay, there we go. So our mass is gonna be on the bottom of the box, usually, right? There's a few tables where they do weird stuff, but there's usually a key that you could check out if you can't find it. But our mass for carbon is 12. We're just gonna round these for convenience. The mass of our oxygen, we're going to round to 16. And then hydrogen is 1. Right? Just seen right there. So those are our molar masses, and we know that our molar masses is in grams per mole. That's the units. which are going to become important for when we need to do dimensional analysis here. So now to find the molar mass of our entire compound, right, we're just going to do some addition here. So we have 2 carbons. I'm going to make it into like a math equation, but you could just say 12 plus 12 plus 4 hydrogens plus 2 oxygens. Okay, so then we're going to add these all up. We got 32 plus 4 plus 24. And you could probably do that in your head, but I'm lazy. I'm going to do my calculator. We get 60 grams per mole is the molar mass for acetic acid. Okay, so our first step was molar mass. We completed that. Now when we want to convert this into moles, how can we do that? What you should be saying to me is, don't we need a mass? Yes, we do, right? Because this is not telling us specifically in a sample, right? We could convert this to moles, but we need some kind of mass here. So let's just say that the mass of our vinegar is 11 grams. We weighed it, we found out it's 11 grams. Now can we find the moles? Very easily, right? That would be finding the moles in our sample. So all we would do is say, in our sample we have 11 grams. Do our dimensional analysis. We know that there are 60 grams in 1 mole. Our grams will go away, and we end up getting 0.183 moles. Now, we can take that and we can convert to atoms. Oh, that page already has stuff on it. So, we know that we have 0.183 moles. And what is our conversion? How many atoms are in 1 mole? Thank you, Abby. 6.022 times 10 to the 23. Right, and we got that from a constant, right? That's a constant. That's just something that you should definitely have written down somewhere in your notes, that 1 mole equals 6.022 times 10 to the 3 atoms. I'm missing the unit, which is the most important part there. We could cross out moles, and we can solve for atoms. Now here's a little shortcut, right? If we just ignore the 10 to the 23, we can multiply 0.183 times 6.022, and then we can just add the times 10 to the 23 to our answer. And we could adjust the decimal if we wanted. But we wouldn't need to here. We get 1.102 times 10 to the 23 atoms. Okay, that's a lot of atoms, but that kind of makes sense, right? Because we don't quite have, if we had 1 mole of something, then we would have 6.022 times 10 to the 23. Here we have 0.18 of a mole, so it makes sense that we would have much less than 6.022. Right? Whereas if you had 70 moles of something, then you're going to have a ton of atoms. Right? So keep that in mind when you're looking at your answer to make sure that it makes sense. Think about how many moles you did have, right? And it would make sense here that we're going to have less atoms than 1 mole. Okay. Dimensional analysis is done. I know, we're so excited because it is a lot, but I think the more examples you see and the more examples you try to do, the better that you're going to get at it. At least that's how it was for me. So if you're struggling with that mole lab, right, please let me know because I'm happy to do a one-on-one session and we could go through some of the examples together. So now sig figs. This is the last thing that I noticed quite a few people getting wrong on their on the lab, the virtual lab that you did. One of the questions asked, how many sig figs do we use on a graduated cylinder? Right? And some people got it right away. Some people wrote, I have no idea. Some people got kind of part of the answer. So I thought we could just go over sort of how you figure this out. So the first thing is, if they give you sig figs in a question, for example, if we look at our Avogadro's number for moles, 6.022, right? We want to basically use the amount of sig figs that the smallest number has. So we were multiplying by something that also had 3 significant figures, 0.183. So we would want to have 3 significant figures in our answer, which I will tell you guys, this is a little creepy. I did that automatically, which tells you how much this has been ingrained into my brain, right? But we had 3 significant figures here, 3 significant figures here. Our answer has 3 significant figures. It kind of makes sense. You wouldn't want to say 1 times 1.1 and then have your answer, uh-oh, my thing is spazzing out again. You wouldn't want your answer to have 1.111117825, right? Because where are you getting all these significant figures from? That doesn't make sense. So some of that is kind of logical. You probably already round in some cases to a default that makes sense to you. That also is because you see that there's 3 and 3 here, so there must be 3 in the answer. Right? When we're reading a tool, it's a little harder. So here's a graduated cylinder that's not a real one, right? But we can see clearly there is water in it or some kind of liquid. When we read the graduated cylinder, there's all these little lines here, right? So we can say 6.6, right, pretty clearly because we could count 1, 2, 3, 4, 5, 6. Well, guess what? We can also guess 1 figure further. So in this case, a totally valid answer could be 6.61. So that's blue, and you guys definitely cannot see that. Right, so a valid answer could be 6.61. You could also say 6.63, right? Whatever you're seeing, you really want to take 1 guess. Now, obviously, you wouldn't want to guess 6.69 here because it's not close to the 7, it's much closer to the 6. But that means that you can go all the way to the 100th place when you're guessing. Okay, so now we're going to practice on a ruler. Same thing on a ruler. You can go 1 guess, 1 figure guess, we will say. So I'm going to draw an arrow on the ruler.
This is still her previous class.
And I want you guys to take a guess at the length of that arrow. And I say take a guess because we all, in theory, could get different answers here. So look at that arrow. Take a guess at the length in centimeters there. And when you think you've figured out the length of the arrow, you could just type it into the chat. Great guess by JD May, 1.63, right? I definitely see that the arrow is coming to 1.6. It's somewhere between 6 and 7, so 1.63 is an excellent guess, right? I said 1.65. I would say, and you're right, I gotta put my units, anything between 1.6 and 1.7 would be acceptable, right, on this kind of a question. So if you said 1.67, 1.69, 1.66, 1.62, whatever, any of those could be valid. Now, what would be wrong is if you said the answer was 1.652, right? Because where are you getting that third digit? You don't have any markings on this ruler that you could guess that far. You can only guess one. You can't guess 2 digits. All right, so I hope that kind of makes a little bit more sense. That's just going to help with accuracy when we're measuring, because if you use 1.6, you'll probably get the same answer, or a similar answer, but 1.63 is a little bit more accurate towards what the actual length of that arrow is. Okay. I know that was a lot of math, guys. Hard to do on a Friday morning, but we did it. So now I want to take your questions. If you don't have any questions about the class, you feel confident, you're getting the dimensional analysis, you're happy with your grades on all your assignments, then you're welcome to leave. Otherwise, if you have a question where to find something, you know, a question you got wrong on a quiz or a test or an assignment, let me know. I will let you know quickly that there is a code word, which I'm going to type in the chat right now. That's the code word for today. There is an exit slip, which asks you to put the code word. So if you were here today for this live lesson, you will get 10 out of 10. If you were not here for the live lesson and you explain why you were not here, you could get 5 out of 10. And then if you do nothing, you get 0 out of 10. So make sure you write that code word down. I made something in Canvas that's not supposed to appear until, I think I made it appear at 10:30, so you should see it now. It is on the last module in the class. It should also show up on your calendar. But if we go all the way to the last module, come on, Canvas. There we go. Virtual sessions and labs. This one is called Virtual Session 3 Check-in. Right, and then it just says include the code word. That's it. Okay, so that's all you have to submit for this. Does anyone have any questions that they want to go over before we end the session? Okay, well then I'm gonna guess that we don't have questions. If you do have a question, feel free to email me or text me, right? Or even in the virtual session check-in, you could leave your question there. And when I'm grading it, I'll see it. Otherwise, hopefully this helped you to kind of see the math and go through the math a little bit more. And I'm gonna go ahead and end the session, and you guys have a nice rest of your day.